which allows us to get very detailed shape information, basically build a topographic map of the surface and start mapping the geologic features in exquisite detail. And then finally, we spiral down to just 230 miles above the surface of this body, which is 600 miles in diameter. And we map its elemental composition, its gravity field, and look at surface features as small as 40 meters across. So by the time we finish in mid-2016, we're going to know Ceres in exquisite detail. We're going to understand why it has bright, very, very bright spots, which are unique to any body in the solar system that's been explored thus far. And we're going to understand what Ceres means in terms of a building block for planets in our solar system. And back to you, Dwayne.
Thank you. And now to Dr. Jim Green, Director for Planetary Science Division here at NASA headquarters. Jim?
Thank you, Dwayne. You know, Dawn is not an acronym. You know, NASA loves acronyms, but Dawn really refers to a mission that's going back in time. It's visiting a region in the asteroid belt. It's been at Vesta, as was discussed, and now at Ceres, the number 1 and number 2 sized bodies in the asteroid belt. And that whole area has been the same for billions of years. It's a region where a planet should have been, but no planet was created. It's a region where Jupiter's gravitational interaction with this region has kept these pieces apart. Ceres, that protoplanet, that beginning seed of a planet, now allows us to look back in time to see how terrestrial planets are put together. It's spherical, which we now know means that it is gravity and its heat inside due to radioactive materials that it has created has allowed material that is heavy to sink to the bottom, probably has a core that's fairly extensive, silicate rock crust, and now we know extensively about its ice shell, but we need to know much more about it. Its ice shell surrounds the body, and it is a beautiful example now of our dwarf planets, those things that are building blocks of planets. So Dawn is just such a wonderful mission to explore that early part of the solar system because it's right here in front of us today. What we learn about from Dawn, about our building blocks, about this region, about these asteroids, I'm sure will also inform us about other solar systems and how rocky planets are created in those locations around other stars. So it's a tremendously historic mission, and we're delighted it's there safely, and we can't wait for the science results to come out. So with that, let me turn it back over to Dwayne.
Thank you all. Before we go into the Q&A, just a couple of follow-ups here. For Mark Raymond, his name was not listed on the advisory. Let me make sure you all have his spelling right. It's M-A-R-C-R-A-Y-M-A-N. That's M-A-R-C-R-A-Y-M-A-N. And again, Chief Engineer and Mission Director for Dawn at the Jet Propulsion Lab. And I may have given out the wrong information on when the pictures will actually be taken. Mark, did you want to clarify when the pictures will come in or start?
Yes, as Carol or somebody said, we're on the dark side of Ceres now, so we're using a combination of Ceres gravity and the ion engine to sort of pull Dawn back towards Ceres. And so we're not taking pictures now, but we will resume taking pictures April 10th. And so we'll take pictures a few more times before we get down to this first 8,400-mile altitude intensive, or this orbit at 8,400 miles from which we take intensive observations.
Thanks for clarifying that, Mark. My mistake on that. So I know Mark is going to have to leave us. He has other commitments. But again, if you have any specific engineering questions, we can get to those at a later time today if we don't have the answers. So with that, let's go ahead, operator, and transition into the Q&A.
Thank you. At this time, if you wish to ask a question, please unmute your phone and press star 1. Again, that is star 1 if you wish to ask a question. One moment, please, for questions to queue. Again, that is star 1 for questions. One moment. We have one question on the line. One moment. Our question will come from Ken Kramer. Your line is now open.
Oh, hi, thank you, and congratulations to the Dawn team and NASA for a fantastic result today. I wonder if you could talk a little bit about what will the spacecraft be doing in the next few weeks before you take images. Talk a little bit more about when you'll also be activating the science instruments. And I think you released one picture today. Are there any others we can expect from March 1st? Thanks.
I can take part of that with regard to what the spacecraft is going to be doing. It's continuing to use its ion propulsion system to reshape its orbit now around Ceres, aiming for this circular polar orbit at 8,400 miles. And in the meantime, it's now going up to a higher altitude. So when it was captured, it was around 38,000 miles in altitude. But on March 19th, it will be at the apex of its orbit, the apogee, a term I know you know, Ken, of nearly 47,000 miles. So it's continuing to thrust. It's reshaping the orbit, changing the plane of the orbit because we want to fly over the poles by flying over the North Pole, then south toward the equator, and then over the South Pole. As Ceres rotates underneath the spacecraft, it gives us a view of the entire surface. And so there's a lot more maneuvering ahead so that we can begin taking the detailed science observations. We've used both the camera and the combination visible and infrared mapping spectrometer, but we have not yet turned on the gamma ray spectrometer nor the neutron spectrometer. That is, we haven't turned them on here at Ceres. Obviously, we've used them extensively before, and so that's going to happen soon as well.
So as far as the better image data, we do have two op-navs before we get into the RC3 orbit. But as I said before, the RC3 orbit is when we will be seeing a big change in our understanding of the surface of Ceres.
Were there any other images from March 1st? That's what I was wondering.
Oh, no. The images that were released, not every image was released, but they're similar to the one that was released.
So there's not going to be a rotation movie or anything like that. Okay, thank you.
No, it was a more limited image acquisition for optical navigation purposes.
All right, thank you.
And as a reminder, if you wish to ask a question, please press star 1 now. Our next question will come from Mike Wall. Your line is now open.
Yeah, hi guys. Thanks again for actually doing this, and congratulations on this big milestone. I just had a question. You guys went into a little detail about what the science is going to attempt to answer. But yeah, I mean, are there any things in particular that you're looking forward to, Carol or Mark? Are there any particular questions you're sort of most excited to try to learn the answers to? Would it be the bright spots, the plumes, anything in particular?
I'll take a shot at that. So the bright spots and the plumes are really kind of symbols of what we're after at Ceres, and it's really to understand how a body accreted from the solar nebula, how it came together from the primordial protoplanetary disk, and then what processes acted on that material to the the body that we see today. And the body we see today, as Jim was describing, we know it has an ice layer because its density is so low compared to rock that we know that it still has rock and ice. But we don't know in what proportion. So we don't know how much of the water came out of the hydrated rocky chondritic material. And so we're after the interior structure. Did Ceres heat up enough that it has a very dry interior with increasing hydration towards the surface, or was there a process by which most of the water was removed without causing a lot of dehydration of the rock? Or so the comparison would be: do we have sort of the leftover hydrated rock with just the lightest watery ice coming up to the top, or did we fully dehydrate part of that rock? And that's important because it speaks to what was going on at the water-rock interface in the past. We think there was an ocean on Ceres. We're based on the heat that would have been coming out of the interior, that the current ice layer would have been liquid in the past. And so that warm ocean rock interface is the type of environment that we recognize would be conducive to life, so a habitable environment. We really want to get back to better understanding what Ceres was like in the past so that we can answer these questions about its potential habitability and how a body like Ceres formed and evolved over time. And ultimately, because there were other bodies like Ceres that likely rained in on the inner planets when during some cataclysmic scattering events, objects like Ceres likely brought water to the inner planets and to the Earth. And so by examining it closely, we get kind of a window into that type of a body that may have been quite important to our own planet's evolution.
Yeah, this is Jim Green. From my perspective, when you look at Vesta, you see how cratered it is, and it's of course half the size of Ceres or so. And then when you look at Ceres, you see also heavily cratered areas, but you also see some large areas that are quite smooth. That's got to mean that the interior has communicated to the surface, and as Carol said, it's changed over time, and that's exciting. The next step, of course, when I look at it as head of planetary science, I know we're going to be flying through the Pluto system, and we're going to be looking also at other icy bodies. So that's going to be another opportunity for us to compare Ceres with Pluto. Now, Pluto is twice the size of Ceres. So there's a normal progression in sizes within our solar system that also allows us to do these inner comparisons. Their position and the raw materials where they are that they've accumulated can tell us a lot about the evolution of our solar system. And so we've got a lot to learn, and Ceres is that next step.
Thank you.
And as a reminder, please press star 1 now if you wish to ask a question. One moment, please. At this time, I'm showing no further questions. I will hand the call back to Dwayne Brown for closing remarks.
Well, thank you, operator. Short and sweet. Again, I want to thank folks for listening in, and we can certainly do any follow-up interviews you may have. I want to thank Mark for giving us an update on where we are now with the images and with the spacecraft. Any images or any other information will be on the website at www.nasa.gov/Dawn, and this conference call will have a replay until Wednesday at 888-562-0226. Thank you again. Congratulations to the team, and have a great weekend. Back to you, operator.
Thank you. With that, we'll conclude the conference. Thank you for your participation. We disconnect at this time.